Everyone, just bear with me a minute while I get ready for our next video. As you know, we've been working our way through Unit 6, Chapter 5 in our textbooks on statistical reasoning. And what I want to look at in this particular video is 5.5, where we look at z-scores. I'm just going to do it in two parts. So the first part, we're going to be taking a look at, what are z-scores? How do I find them? What do they mean? What am I learning about the data by calculating something called a z-score? Okay, let's take a look at the vocabulary you're going to need to watch for. You have the z-score, the standard normal distribution, and the z-score table. Three things that I want you to be on the lookout for as you listen to this video. So, what are z-scores? Well, first of all, just to explain what their purpose is, let me ask you a question, and that is, if I'm going to try to compare some data, but the data has different means and different deviations, it becomes a little bit tricky to figure out, well, how do I evaluate these two things? Let me show you an example of what I mean by that. The following is a situation where we have some data about a running club in Vancouver, and in particular about two individuals, one named Haley and one named Serge. Now, this running club is training in two different locations, one in Vancouver, which of course is at sea level, and the second spot is at Lake Louise, which is well above sea level. And it's known actually that we do run faster at higher altitudes. But the question is, numerically speaking, how do we actually know that by looking at this data? If I look at what the average time was for the club at 25.75 with a standard deviation of 0.62, just looking at Haley's running time, she is definitely faster than the average one in the clubs. And I look at her time in Lake Louise, same thing. It's a different mean, different standard deviation, but she's still lower. The question really is, at which time was she actually better? When was she running faster than the other? And how would we calculate that? Well, it's kind of hard to calculate it right now because we've got different means and different standard deviations. So, how do we compare these two things? It's much like trying to compare an apple to an orange, they're different. And so, we need to be able to compare results in a way that they are somehow first standardized. And so, wouldn't it be simpler if we could somehow evaluate everything on a standard normal distribution system? Well, it so happens there is such a thing, and that is where the mean is a 0 and the standard deviation is exactly 1. And it looks like this, a very simple, normally distributed graph. You've got a mean of 0, you've got the standard deviations that are clearly just 1, and you have your percentages as you're used to from the last video. We call this the standard normal distribution. And when we place values on this, we call these values the z-scores. A z-score is a standardized value that indicates the number of standard deviations of a data value above or below the mean on the standard normal distribution graph. So we're going to try a couple of easy examples so that you can get a hang of it. So what we have is a guy named James, and he's 168 centimeters tall. In his high school, boys' heights are normally distributed. They have a mean of 174 and a standard deviation of 6. So I want to know, what is James' z-score? Well, if I think about it, okay, 168 is 6 centimeters lower than the mean. So that's like negative 6. And if I have a standard deviation of 6, that's like a z-score of negative 1. What about if we did one for a height of 174? Now, 174 is exactly the same as the mean, so it's right at the 0. How about if it was a height of 180? Well, 180 is 6 centimeters above the average. If my standard deviation is 6, then that's going to be a plus 1. And lastly, if I had a height of 177, well, 177 is about 3 centimeters higher. And if I take that and divide it by the 6, I get 1/2 or 0.5. So z-scores are actually calculated in a very straightforward manner. To find a z-score, you take the number you're working with, you subtract the mean, and then you divide the whole thing by the standard deviation. And that will give you this number we call the z-score. So let's give this one a try. A class of 135 students took a final exam in math. The mean score was 68% with a standard deviation of 8.5. Now we're supposed to find the z-score for the following students. So Michael scores 78. So we take 78 minus 68 divided by 8.5. We get a number of 1.18. Now, if we look on our graph, what that means is that Michael is just a little bit beyond the 1 somewhere on our graph. Let's try the next one. Hank. Well, we would take 55 minus 68, and then we divide by 8.5. This time we're getting a negative, and it's a negative 1.53. If I put that on my graph, then Hank is scoring somewhere right about here. And lastly, Bree. 89 minus 68 divided by 8.5 is 2.47. Putting that on a graph, she's somewhere up here, like way up where very few people are. So not only do z-scores help us standardize things, but z-scores can also help us find the actual exact percentage that something is sitting at. And in order to do that, we first used tables of z-scores, tables that look like this, where you have the original number, you can see 1s and 2s and 3s, and you have a tenth. And to get the 100th, you go across. So what do I mean by that? Let's go back to Michael. Now, I think I've got these scores. Yeah, it's 1.18. So let's look at it, a blown up version. Here's 1.1, and I look all the way across to get to the 0.08, and here it is, 88.10. So Michael is sitting at 0.8810, which is 88.1%. What about the others? Okay, how about Hank? Hank was at negative 1.53. And so he's somewhere here. Let's see if we can find him on a table. I do believe, I could have sworn I put that table in there and I don't see it anymore. And so, I know what I was going to do. Sorry, I do remember. What I was going to do was to go to the table. So let me just get the number. This is negative 1.53. So here's my table. Negative 1.5 is right here. And then I go across until I see that it's a 3. Looking up, it says 0.03. So here it is, 0.0630. So he's at 6.3%. And then, I raised the wrong thing here. Let's do this guy. Maybe it's underneath. Sorry, it is underneath. And so let me just put it. Don't know if I can get it actually without moving. It's just a hair. There we go. There. Okay. So then the next one I want to do is actually for Bree. Now Bree was 2.47. So let's just go quickly to this guy, 2.47, huh? So here's 2.4, and I go all the way across until I get to the spot where I see it's a 7.9932, so 99.32% for Bree. Okay, that's about as far as we need to go for today, for part 1. So your homework is a combination of normal distribution and a little bit of z-scores. And here you have it. I'll pop it up there so you can see it before I finish the video. And make sure you give this homework a try and bring it back next time and we'll talk about it. All the best, everybody.